Alright, hey guys, I am going to be talking to you guys about simulations like the ones we did in class and how they're going to show up on the AP exam. Now, the AP exam technically is designed to where the calculators are not required. So the way that they will test things, as far as like pretending you don't have a calculator, what if you need to get a random number like we did today between 1 and 6? So the way that they do this is they actually require that you know how to use a table of random digits. And as you can see on the screen, it is truly a table of random digits. So today I'll just kind of show you an example. Today we were randomly selecting numbers from 1 to 6. So a way I could do the same thing but with a table of random digits is I can start somewhere. They would maybe tell you which line or tell you exactly where to start, but let's just say I start at line 108. So if I was doing my simulation today, my first number would be 6, okay? So maybe let's let that person be the one that had the flu, okay? So then the next number is 0, which we didn't have anything assigned to 0, so we would just kind of skip that number. Same thing with 9. Okay, so the first person infected was person number 4. Again, 0 we don't use, 7 we don't use. The next random number I got was 2. 0 we don't use, 2 we don't use because that's the number that we just had, and the next number is 4. So 4 has already been infected by the flu, so we would stop this trial, and person number 6 only infected person number 4 and person number 2. Okay, so 3 total people infected by the flu in this example. So you see how we use the table of random digits. It can be used in a lot of ways. Like that example I used was just a 1-digit number, but let's say that we have other things we could use 2-digit numbers. So like that's the number 19 and 22 and 39, 50, 34. See how that works? Or we could even do larger numbers, 192, 239, 503, 405. The gaps in between really are not affecting the random digits. They're just helping you keep your eyes straight, I guess. So just kind of ignore the gaps in between and you just go straight across. You really would ignore these lines over here, but that's how a table of digits, a random digits work. Now, an acceptable abbreviation is TRD. So if you wrote TRD on the AP exam, they would accept that abbreviation to be table of random digits, okay? All right, so that's what we have to use instead of using a calculator, okay? Now, what I really wanted to talk about today is what if, now these mostly show up on free response questions, so what if it shows up as a free response question? They ask you to, they give you a situation kind of like the flu example, and they ask you to describe a simulation and then carry it out using a TRD. What would you need to write? So you're going to learn in this class that I use a lot of acronyms. So our first acronym is ADS. Okay, ADS. So that means that basically if they ask you to describe a simulation, hopefully you remember to use ADS, and each of these letters is going to prompt you to write something. So basically the answer to this free response question is going to be kind of like a paragraph, okay? So let me go through each letter and tell you what I mean. Starting with A. A means you need to assign some digits to represent the correct proportions in the or the items in the population, okay? So basically your probabilities, you need to assign some numbers to those probabilities. Now, we did that today. I assigned numbers to each person, okay? So we would need to write that down. So we would say, if we were starting it, we would say let 1 represent Lucas, 2 represent whoever, Sally. Okay, so you get the point. All the way to 6 okay, so that's what we're doing now. This was just how this example is. We'll be working through many examples over the next couple of days. But you see here in this screen that, sometimes it's not going to be items or people. Sometimes it could be proportions. Like look up here. It says, what if the situation is 70% of people, 73% of people are boys, and we needed to assign numbers? Well, the correct proportion or the correct probability would need to be, let's represent the numbers 00 to 73 to be boys and 73 to 99 to be girls. So 100 total digits, 73% are boys and the other percentage are girls. Okay. So a couple of notes, speaking of that 100%, notice that I started with 0, 0. It's sometimes tricky for you guys to think about, but if I do 0, 1 through 100, that is 100 digits, 100 total items. But so is 0, 0 through 99. That's 100 digits as well. Okay, one thing to note when we're using the TRD, we need to use the same number of digits every time. Okay, so I can't go like going by 1 digit and then all of a sudden switch over to 2 digits and then maybe to 3 digits. No, we have to either, for the whole simulation, go 1 digit at a time, 2 digits at a time, or 3 digits at a time. We got to choose ahead of time. So the problem with 0, 1 through 100 is that this 0, 1 is 2 digits and then 100 is 3 digits. If we weren't careful, maybe you wouldn't even put that 0 there. You just did 1 through 100. Hey, that's 1 digit and that's 3 digits. Okay, to move along the table of random digits, we need to be the beginning numbers and the ending numbers need to have the same amount of digits. Okay. So if you have 100, like you're doing a proportion out of 100%, using 0, 0 to 99 is helpful. You could use 0, 0, 1 to 100, so 3-digit numbers. There's nothing wrong with that. But if you're working through a table of random digits, if you only use 0, 0, 1 through 100, that means all numbers 101 to 999 you wouldn't be able to use. You'd be discarding a lot and it would take you forever to work through the table of random digits. So sometimes the hardest part is the A, assigning the numbers, the correct numbers to the situation, and that's why the more simulations we do, the better you can get at them. But it's kind of hard right off the bat to give you something that works always. So it just kind of depends on the situation. So we'll keep practicing each of those. But for the flu example, we're just using the numbers 1 through 6, 1-digit numbers. Okay, and both the first number we assign 1 and the second number we assign, last number we assign 6 are the same size, same digit. Okay. So that's what we would write for assignment. All we're doing is saying let these numbers represent this. Okay? All right, the digit movement. All right, then this is the next sentence we're going to write. And basically this sentence is always going to say move along the TRD, table of random digits, blank digits at a time. Representing blank. Okay, that's kind of a, I know this is not great teaching, but I have learned that kind of doing more of a fill in a blank and kind of you learning that and practicing that helps you guys to say exactly what they want to hear. Okay, so what we're going to do is we're going to move along the table of random digits one digit at a time. For the flu example, we went 1, 2, 3, 4, 5, 6. When I showed you at the first, we just did one digit at a time. If it was a 2 digits, then you would say 2 digits here, 3 digits, etc. Okay? And we would say representing, and this is where you're going to put your component. Basically, it's saying, like, when you're moving one digit, what is that representing in your situation as you move along the table of random digits? Okay? So going back up, I'll show you. We were at this 108. So we started with 6 and then we went to 4. So what did it mean? Well, that just meant that the next number, when we moved that from 6, one digit over to 4, we just found a newly infected person. Okay, that's what that represents in our situation. So I'm moving along one digit at a time, and as every new digit I find is representing a new tenant being infected. So really you need to, bring the context of the problem into this. So basically every second sentence in this situation needs to kind of go along with what's in pink, and you fill it in for however many digits you're using on the TRD. Okay. The second D in adds is discards. So sometimes there's some digits that we need to discard, and we actually did that in this example, the flu example. I was crossing out some numbers that didn't have any meaning, that weren't represented. Okay, so we need to talk about that. Okay, our goal as we're writing this or describing this simulation is for someone to be able to follow your instructions and replicate it themselves. So they need to know, like, what am I supposed to do with this number 9? It's not assigned to any value back up here. 9 is not assigned to a particular number. So in this case, I would say discard digits 7 through 9, right? And 0. Those are all of my unused single digits. Okay? So I would need to tell whoever's reading my simulation that that's what I'm supposed to do with those leftover digits. Another thing we need to think about is, what about repeats? Okay? So you need to talk about the repeats. So in this case, if I come across, like if I was at 2 and the next number I got was 2, we were throwing that out because that person 2 is already infected and they can't visit themselves or get it from themselves. So we would say discard digits 7 through 9 and 0 and repeated digits. Okay, so far we got 3 sentences, and we're down to our last sentence. S, selection. So when is our digit selection complete? Basically, when is a trial done? Okay, when is a trial finished? How did we know when to stop today when we were running these simulations? So I would write in this case, remember we continued until kind of 2 situations. We continued until a repeated digit was found, which we can kind of clarify a little bit better. The person was already infected, so therefore couldn't get it again, right? Or we also stopped until all 6 digits were selected, meaning everyone was infected. Okay, so so you basically need to say, hey, keep doing this until when. So you need to tell the person who's reading your simulation that you know when you're supposed to stop. You know when a trial is done. This is kind of, the S is kind of two things. We also need to define the response variable. And the response variable is just a fancy vocabulary term for the outcome of the trial. Okay, so basically we need to tell the person that's reading our simulation description what do we write down at the end of a trial? Like, what are we looking for? And remember, our question was, what's the probability that 6 people were infected with the flu? Okay, so at the end of each trial, we were writing down how many total people were infected within that trial. So we need to tell the AP reader that. So all right, we can say when this, or at the end of each trial, record the number of people infected. PPL, not an inappropriate abbreviation, but just trying to save time there. And we did it. So those combined 4 or 5 sentences that we did under each of these, that would represent what you would write down on a free response question asking you to design a simulation. Okay, so I'm going to do one more example, kind of fresh, leaving the flu example behind and giving you another example right here. Okay, and then in class we are going to do some more together as well. Okay, so this example says researchers recruited 20 volunteers, 8 were men and 12 were women, to take part in an experiment. When they did this experiment, they split them into 2 groups, 10 each, and they were surprised that in one of the groups, all 6 of the 8 men were in that group. They were assigned to the same treatment. So should they be surprised? Let's simulate it. And it says to do 5 trials. So usually we'll tell you how to doing 5 trials, and it says use the TRD to estimate the probability. Here's our question. Estimate the probability that the random assignment puts 6 or more men in the same group. Okay? So the first part, and I told you this is sometimes the hardest part, is doing our assigning. So we need to kind of go back up here and think about what's our population. In the flu example, it was the 6 people in the apartment. In this case, it's the 20 volunteers. Okay, so when I assign my digits, I have a total of 20. Okay, notice that 20 is 2 digits. Okay, so I'm going to give you lots of situations. This is always hard for me to grade because there's so many different situations here. But let me kind of show you a few examples of how you could assign the appropriate digits. All right, so first we could one example would be to let 1 through okay, so first we could say, okay, let me kind of start here. Since there's 20 volunteers, one thing that we could do is use all the digits from 1 to 20. Okay, and the problem with that is that the 1 is only 1 digit and 20 is 2 digits. So technically we would use all the digits from 0, 1 to 20. Okay, you could always start at 0, 0 and use 0, 0 through 19. That's 20 digits. Okay, so either one is fine. Okay, so I could say let 0, 1 through 0, 8, that's 8 digits, represent men. And I could let 0, 9 through 20 represent women. Okay, on the same, like if, let's say I was using 0, 0 through 19, I would say let 0, 0 through 0, 7 be men. And I could say 0, 8 through 19 be women. Okay? In both of these cases, when I get down to the second D, I'm going to have to do some discarding. Okay? I'm going to have to, in this case, I'm going to have to discard numbers 21 and higher, so 21 through 99, and then also 0, 0. So I've got to discard those eventually. If I use this example, I would have to discard numbers 20 through 99, 2-digit numbers 20 through 99. And in both situations, that's a lot of numbers to have to discard. So let me give you one more assignment that we could do, digit assignment that we could do, so we don't have as many discards. Now, there's nothing wrong with having a lot of discards. I'm just trying to show you all different options. Okay, I noticed that 8 out of 20 is 40%. And I noticed that 12 out of 20 is 60%. So I can actually set up more of a proportion. So I could use digits 0, 0 through 99 and let 0, 0 through 39 represent men, and 40 through 99 represent women. Okay, because 8 out of 20 is 40%, and that's 40 digits. And then 12 out of 20 is 60%, and that is the number of, like, the same proportion of women there. That's 60 digits. Okay, so it's the same chance, like as using the blue, but in this case, since we're using all 2-digit numbers, 0s and 99, we would have no discards. Okay, so all of these situations, and there's more, are acceptable. It's just kind of up to you and how your brain works. Okay, so either way, whatever way you decide is totally fine. I'm going to leave maybe these two up here, and we'll kind of think about each of these two as we continue, because those are probably the most popular. Okay, so that's the A, right, and adds. The first D is digit movement. In both of these cases, we will move along the TRD 2 digits at a time. Representing, remember that pink fill in the blank I gave you? Representing, and what we're doing each time we are picking a number on our TRD, each time we move 2 digits, we are assigning a person to a treatment. Okay. All right, our second D, remember that's our discards. So regardless, we need to discard repeats. And most of the time right now, we will be discarding repeats. I will talk to you about situations where we don't, okay? So as far as this blue situation, I would say and digits 21 through 99 and 00. That's that case. And then in the pink case, I would not even really mention anything, right? Because I would just say discard repeats. And there were no extra digits from 0 to 99. There's no other 2-digit numbers to have to discard. So that part just kind of depends if you chose the blue or the pink. All right, now the S, the selection. How do I know when we're done? Sometimes it's kind of like we got to go down here and start with our, just kind of pretending that we're going through to kind of fill this out. So let's do the blue first here. All right, so if I pretend to kind of move along the table of random digits 2 digits at a time, it seems like the first person I got is 19, which in the blue represents a woman. So it looks like my treatment, when I assigned the treatments here, the first person I got was a woman. 22, discard, 39, 50, 34, 5. So the next person I got was a man. I don't know how long this is going to take. 13, the next person I got was a woman. Okay, and you can continue on and on and on through this doing that. How do I know when to stop? Oh, well, each group had 10 people in it. So I probably need to stop when I have gotten 10 total people here. Okay? Because then the group is finished. So continue until 10 people have been chosen. Okay, and what are we going to write down? Well, remember, we're trying to figure out the probability that random assignment puts 6 or more men in the same group. So we need to, at the end, record how many men are in the group. Now this can get a little bit complicated because we've got to be careful. It's not unlimited men, right? Like we can't go over 8 and we can't go over 12 women. Well, obviously we can't go over 12 women in a group. So it may be worth mentioning here, like so maybe just say there can't be more than 8 men in a group. So there's no way to get 10 men in a group, even though the random numbers may, I mean, it's very rare, but even though the random numbers may come up to have 10 men randomly, 10 out of 10 were men, that's not possible because there were only 8 men. So we do need to kind of write that down to let people know. Okay? So there we go. We have written down as far as the design part of that free response question. Okay? Actually carrying out is what I was starting to do. And it may be a little bit faster to do this using the pink right up here example, less discards, right? Of course, you can't switch back and forth. If you choose blue, you gotta stay with blue. If you choose pink, you gotta stay with pink. But just for time's sake, I'm gonna stick with pink just to show you, okay? All right, so if you were asked to carry out a simulation with 5 trials, I would recommend setting up a little table, just like we did in class today. So I would say, there will be 5 trials. And I would kind of keep track of, so my selections, and then my response variable at the end, the number of men. Okay, all right, so I'm just going to start at the top just to go, but the first person is 19, which according to my pink is a man, and then 22, which is a man, and then 39 is a man, 50 is next, which is a woman, 34 is next, which is a man, 5 is a man, 75 is a woman, 62 is a woman, 1, 2, 3, 4, 5, 6, 7, 8, 2 more, 87 is a woman, 13 is a man. Okay, so there's my selections, and out of these 10, so I've assigned these people to a treatment. Out of the 10, 1, 2, 3, 4, 5, 6 were men. Okay, and then on my table, they want you to kind of write on the table. And since I'm finished with that trial, I'm going to put like a little bar and just write above this trial 1. Or I can just do a little 1 right there to show that that was the first trial. And then I keep going. 96, woman, 40, woman, 91, woman, 25, man, 31, man, 42, woman, 54, woman, 48, woman, 28, man, 53, woman. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There we go. And this time I had 3 out of 10 men. So I would continue this for 5 trials. So let's say that the 3rd trial I had 5. And the 4th trial I had 8, and then the 5th trial I had 2. Just kind of guessing, I don't know. Then at the end, I'm trying to estimate the probability that the random assignment puts 6 or more men in the group. So notice that happened 1, 2, so 2/5 out of the time. So my estimate for my probability would be 2/5. So I would just kind of write out that, which is 40%, right? So my estimate for the probability of being 6 or more men would be 40%. Okay? All right, so hopefully you took some notes, you wrote this down, and you will come to class with lots of questions. We are totally not moving on. We will be doing more examples together in class, but at this moment, write down what questions you have so we can talk about them as a class when we see each other next. Okay? Thanks, guys.